Hi, welcome back to video 2 on this tutorial about Postgres clustering. In the last video we did a brief introduction to what we're trying to do, which is to understand the way in which Postgres replicas work and a little bit of an introduction to PostgreSQL itself. And in this video we're going to look really at what we're sort of aiming for, so the landscape really of what we're trying to build. And I'll finish by giving a brief demo on some of the tools that I'll be using just to make my life slightly easier. Now, when it comes to clustering architecture, a lot of terms are used interchangeably when talking about a database cluster or a web server cluster or any kind of infrastructure cluster that you might be thinking of. But really what we want to do here is to try and learn some words that Postgres uses, so that when we then start looking at documentation and some of the other things later on, that we'll make sure we understand what the words actually mean. And particularly when it comes to the word cluster itself. So in Postgres, a cluster is a set of one or more databases in a group. So a cluster isn't the 3 nodes that you can see on the page here. A cluster is a group of databases hosted on a Postgres database server, usually but not necessarily replicated across multiple nodes. So straight away, that's really important that we understand that a cluster in Postgres terminology is a group of databases. So what we might traditionally call in SQL Server, we would call it a database server, but they call it a cluster. Now, there is a default cluster. And when you install Postgres on most of the package managers, you will get a cluster called main. That's just a name they've chosen at random. It doesn't mean anything. You call it whatever you like, but it's called main. Now, a node can hold multiple clusters, and each cluster can have multiple databases, like we already said. So why have we got this seemingly quite complicated level of abstraction here? Well, the simple answer is because you can set different access permissions and different replication topology for each cluster. So you might say, well, cluster main has a set of databases and they're all accessible to this service, this automation tool, this user. Whereas maybe I've got another cluster which is called customer services, and maybe the other cluster is only accessible by the customer services team and maybe a different set of automation or whatever. So let's look at an example here. So in this cluster, we can see, in this example, there are 2 clusters. One is called main and one is called events. And if we look at it here, the reason I've highlighted this in green is to say on server 1, I've called it PG1 just for the sake of it, we can see that cluster main's primary, in other words, the database that allows you to write to it, is on Postgres 1, whereas the primary for the events cluster is here on Postgres 2. Postgres 3 has a replica for both clusters, and you see Postgres 2 here has a replica of that, and Postgres 1 has a replica of that. So you can see here just one example of why you might decide to have separate clusters. In this case, we're getting PG1 to do most of the work for the main cluster, but PG2 to do most of the work for the events cluster. So it's a way of spreading out the workloads, particularly if you've got databases that aren't necessarily very busy or very large, but they're maybe large enough to cause a risk that you don't want PG1 to be the primary for both of them and be doing tons and tons of work. So you could do stuff like this. As I mentioned before, you can also set different permissions on those clusters in order to lock them down individually. Ideally, each node here, each server if you like, which is likely to be a virtual server but not necessarily, each of these ideally will be identical. And I say identical in as much as they'll have the same amount of RAM, the same number of processor cores, and ideally the same processor type as well. But more than that, also to have the same folder layout. Now the reason this is important, and you'll find it when the first time you do a failover, is the last thing that you want to happen is right in the middle of an unplanned failover you suddenly realize that because your folder is in a different place on one of your servers, that the failover fails and says, oh, I can't create a database there because there isn't a folder there, or you need to tell me what the correct folder name is. And you really don't want to be spending your time messing around with different locations. So the more identical you can make these, the easier it is. The other reason it's really important, and as you see here, the reason that I don't call this primary and secondary 1 and secondary 2 is because of the nature of a failover. The first server is not always going to be the primary for this cluster or for events cluster. It might be, but if I need to fail over permanently, maybe PG1's broken and I need to replace it, so maybe I have to retire that server. Well, if that's called secondary 1 and secondary 2, that's going to be really confusing if secondary is running the primaries. So we avoid labeling the servers with the word primary or secondary, because the primary or secondary is a virtual concept and it moves between them. The best idea is just to use something like PG1, 2, 3, whatever. You could include your location in it as well if you wanted to, PG1-London, PG1-Scotland, whatever it is. And in here we treat them all identically. So if I do need to delete one of these, so let's say at some point PG3 dies, then it's very easy to just say, well, I'm going to kill it off and I can create a new replica really easily, really quickly, and I can call it PG3 again. It really doesn't matter, because that name is purely used for sort of a logical identification of the physical server or the virtual server, and it doesn't necessarily tie directly to the databases that are running. So we keep these all fairly normal, fairly standardized, and it's just various parts of the cluster that are marked as primary depending on the node. So let's talk a bit about replication. So like most database systems, we replicate in a high performing way by sending the logs, the data logs, to other nodes. So if you think about it, you have a data table. Let's just say you've created a new one, there's nothing in the logs. Every time you make a change, every database engine, if you have full transaction logs enabled, which you would do for replication, is an entry gets added to the log to say this column in this row in this table got changed from that to that. And that can be sent to another node, and then on the other node they can apply that same action from the log to their own table, so that their own table keeps in sync with the primary, right? That's the whole point of replication. Now in Postgres, these logs are written before the data is committed to the database table. Now that might seem a little bit round the wrong way. In most database servers, they're going to write to the table, and then once they're happy that the table has persisted, then they're going to write to the log, so that that change can then be sent over to the other node. Now the problem with doing it the traditional way is if you write to the table and it works, but then somehow writing the log fails, then you're going to not have a log to send to the other server. The other server is going to be out of sync. Now, it's not necessarily likely or very common, but it does happen, and it can cause data corruption. So in Postgres, we do it the other way. We call them write-ahead logs. So we write it to the log first, and only when we're happy that it's been written to the log successfully do we then commit it to the table. Now, you might argue, therefore, that isn't this just the same problem? What if it writes to the log successfully, but not the table? Well, that's fine, isn't it? Because if it doesn't write to the table, we know that we haven't updated the table with the latest log. So we can apply it a second time and we're up to date. And likewise, it doesn't matter if our replica gets that log and applies the change slightly ahead of the primary, because they'll all catch up because the data has been captured in the log first. So that write-ahead log process is quite key to how Postgres works. Now, most of these are not important for us to know in deep detail, because Barman and Rep Manager take care of how these WALs are actually applied, but all we really need to know is each one of these logs is an individual file on disk, and it gets written to, and after a period of time, or after it gets to a certain size, a new log will be written, and then the old one will be deleted eventually, but we'll talk about log lifetime later on. Now we do need to think about some of these things, and we will look at these parameters that control how the logs are written when we start looking at installing Postgres. But just for now, we just need to know, we're going to see this phrase a lot, this WAL, write ahead log. We're going to see it crop up in Barman, we're going to see it crop up in Rep Manager, and when we start actually doing this for real, we're going to see that referred to a lot in log files and stuff like that. So it's important that we sort of understand what they are. Now, there are some more things we just need to mention about WALs. Again, we touched on these a little bit. The primary server doesn't know which logs have been consumed by a replica. I mean, in essence, it's not in charge. The primary isn't in charge of making sure those replicas get written to. It's the replica's job to connect to the primary and to request all of the logs that it needs. Now, why is that an issue? Well, it's an issue because if the replica stops streaming those logs, or if it falls too far behind, then eventually the primary is going to reuse the old log file again for a new set of logs, rather than just creating new ones all the time. Obviously, there isn't unlimited disk space, so it's going to keep a certain amount of logs. There's two parameters mentioned here, the max WAL size and the WAL keep size. So we can define the WAL keep size is effectively what's the minimum amount of logs that are kept. So if I'm worried that my replicas are struggling to keep up, I might increase that to say, let's make sure I've got at least 4 gig of log files before the primary starts deleting them. But if for some reason, even whatever size we set that to, if the replica falls too far behind, eventually it will need logs that no longer exist because they would have been overwritten, and at that point the replica is unusable. It's not going to be up to date, and it's really important that you know this is going to happen. We'll see an example of how we do that later. And if that happens, we have to immediately take it out of the cluster so people aren't reading very old data from it. We'll need to reinitialize that as if we're creating a brand new replica, which again, it's not difficult, but we need to be ahead of these things so we know what to do when it happens. Monitoring this replication lag is absolutely crucial. So I'm going to tell a story in a later video about something that happened at GitLab, which is a very chilling story of why we need to make sure that we're actually looking after our databases properly. But one of the ways in which they caught the fact that there was a problem was because they were monitoring the replication lag, and that lag should be, milliseconds maybe at max, but even if it got up to a couple of 100 milliseconds on a really busy database, if it starts getting into a second or longer, then there's a good chance you've got a big problem. It might be a network problem, but it might also be that something is so unbelievably overworked that the replica can't keep up. Maybe there are just too many logs and it can't eat them quickly enough. And if that jumps up, you need to do something, because very quickly that's going to become a problem. Again, we'll look at that more specifically later on. So we need to basically look at what we're trying to do, what I'm going to do over the next number of videos. So we are going to create and configure a primary database cluster on a node. We're just going to do that out of the box by installing Postgres from package managers. We're then going to set up Barman, and we're going to configure the backup. So Barman, as I say, is the backup and recovery manager, and it's Barman's job effectively to set up a replication connection to the primary database. It's going to be streaming the logs just as if it was an actual replica, but rather than rebuilding the database on the Barman server, it's just going to store them as files. And they are useful for recovering. If we lost our main database and we needed to get it from a backup, we could do that. But the main use for us with Barman is to be able to use those logs as a source for new replicas. So if we create a new replica using Rep Manager, we can use the Barman backup and the logs that it has already stored to save us having to go back to the primary for each replica and say, can you send me 50 gig of data please, so I can create a new replica. So the interaction between Rep Manager and Barman's super useful for creating those replicas. And once we've set this all up, we're going to look at a number of failover scenarios, and I've got an app which I haven't quite finished yet, but it's going to be a very sort of noddy little app just to demonstrate what happens at various stages, just to help us understand what, when a database goes down or when it fails over, what's actually happening under the covers and how does it affect the application. One of the ways in which I'm going to do this is using something called Vagrant. Now again, I'm not going to go into any particular details. I'll show you in a second what a Vagrant file looks like. But Vagrant is effectively an automation tool for virtual machines. So if you've ever set up a virtual machine the old-fashioned way on VirtualBox or Hyper-V or whatever, then it's pretty long-winded, right? You have to sort of new virtual machine, select an ISO, tell it the size of the disk and everything, run it up, run the installer, blah blah blah. It really is quite a pain to do that, and if you're doing it a lot, it's a bit of a waste of time, really. So what Vagrant can do is you can say, right, in my virtual machine I want it to use 4 gig of RAM and 2 CPU cores, and I want it to be based on Debian, and I want to install these few things. And then what you can just do is you can tell Vagrant to start it up, and then there's no installation, no going through all the menus, selecting stuff. It just works, and it will start it up for you, and you can even log in using SSH directly from Vagrant. So we'll see that in a second. Now, Vagrant, the way I've set it up is pretty basic. So I've literally just got a couple of lines of bash code using apt to install a few things. You can go crazy with it if you know things like Puppet, Chef Ansible, the sort of automation tools. You can plug those into Vagrant as well. So if you want, let's say, a quick VM that has an entire cluster installed on it, well, you could configure all of that with an Ansible playbook, and you could get Vagrant to run that playbook when it starts up the VM. The cool thing about it then is I can send it to my mates or my colleagues at work, and they don't have to recreate everything that I've already spent ages doing. I can just write an Ansible script and say, here's the Ansible script, here's the Vagrant file, now knock it all up. And in this example, I'm using Debian here. I'm just having a play with it, really. Ubuntu, obviously very similar to Debian. Interestingly, Ubuntu 2204, which is latest LTS until next year, uses version 14. That's pinned to version 14 of Postgres. Debian, whatever version that is up to, is pinned to version 13. No real big differences for the purposes of what we're doing, but I'm using Debian just in case you're wondering. And then my setup is, as you'll see in a second, we're going to set up 3 database servers called Postgres 1, 2 and 3. Again, they're not called primary, they're not called secondary, they're just called Postgres 1, 2 and 3 because we're going to be moving the primary between them. 1 Barman server, which we're going to store the backups on, and this local app, which I haven't finished yet, which I'll run locally rather than in a VM, and that will point to the cluster to demonstrate what's going on. Now there is a tool called PG Admin, Postgres Admin, which is probably the most popular GUI for accessing Postgres databases. I do have that installed, so later on we'll probably see that as well. If we just want to look at the data in a database without needing to use the app to do it, then we can use PG Admin. But again, I'm not really going to talk much about that. So without further ado, let's basically demo the sort of first piece of this and just see how it actually works. So I have VirtualBox running here. You can see, don't worry about these two at the moment, they're just other VMs that I've got in there. And I've created a Vagrant folder. You can see dev testing is actually this one. It was when I was running some Ansible stuff against my other servers, but don't worry about that for now. You can see here that these are the 3 that we're interested in, and obviously Barman as well. So if we just pick one of these, for example, that folder gets created when you first create the Vagrant file, so there's nothing in there that needs to concern you. But once you've installed Vagrant, it's like as easy as creating a Vagrant file, which is just a text file. So if I open that, oh, picked the wrong one, that's incredibly annoying. Edit there. If we open this, this is all it is. Okay, so it's a Ruby file ultimately, but it's just text. You can see here that there's a few little bits. Again, I don't want to go into loads of detail about this. Version 2 of Vagrant config. You can see some generic settings which apply whether you're using Hyper-V or KVM or VirtualBox or any of the other hypervisors. And you can see here you tell it what image you want to base your box on. In this case, it's the Debian Bullseye 64-bit. There's a bit of a problem. I can't remember if it's the Debian images or Vagrant, but there's a sort of SSH kind of error or HTTPS error when you try and download it, so I have to set insecure is true. And then configuring the network is a little bit hit and miss in VirtualBox, unfortunately. I've managed to kind of get something working. I think the private network basically uses a internal network, a host-only network, and the other one here, public network, gives it one of their NAT, built-in NAT networks that can connect to the internet. And they give it a host name. And because this is VirtualBox, the way that you configure it, you can see here, these are things specific to VirtualBox. These might have different names if you're using Hyper-V or KVM, but otherwise Vagrant works on all of them. It's just the parameters slightly different. So 2 gig and 2 cores. And then this bit, again, is a bit of sort of ugly syntax, but all it's really saying is run apt-get update. And then for the Postgres servers, install PostgreSQL. That's going to be version 13. Really, I should specify version 13 just to be explicit. It's unusual for a major package version, major distribution, to change its default package up a major version, because that would screw everything up if you did a dist upgrade. But you can do it explicitly, or you can do that one and get the latest version, but I think that should work fine. And then I'm also installing Rep Manager and Barman CLI. So Barman CLI are utilities that Rep Manager needs. We don't need to worry at this point in time what all those things are, what they do. All we need to say is we're just going to kind of provision this and get it up and running. I will, at some point, by the time I finish the last video, put a link on them to a GitHub page which will have all of these on it, so you can use them and, you know, change them around to do what you need to do. But in here, if I open PowerShell, for example, in this box, in this folder, and if I do Vagrant up, so all that's going to do is Vagrant's going to run. It's going to find the Vagrant file. It's going to look at the state of things in the metadata folder here. There's nothing that interesting in there that you change, but lost my thing. And it's going to check a few of those things, and you actually see here it's created this and it started it up and it's running, and you can see it's done various things. But once it gets down to after a while, because I've just created this from scratch, it's obviously take a little while for it to do its cloud in it. But you'll see down the bottom eventually those apt-get commands that we saw in the Vagrant file will be run, just so that it installs everything ready to go. So yeah, we'll fast forward this bit in a second. And then what I'll do after this is I will start up the other 2 Postgres boxes. They're absolutely identical. The only difference is they have a different IP address and a different host name, but obviously it's exactly the same spec. And Barman is slightly different because it has slightly different packages. The Vagrant file is otherwise identical in terms of spec and everything, but the only difference is here is we do a few slightly different things in the Barman. So we install a couple of different packages. So cron and rsyslog are needed. Cron runs the Barman backup thing, and rsyslog, depending on the image, the minimized Ubuntu one doesn't include rsyslog, but you kind of need it to get all of your event logs and stuff. And then there's some Barman setup stuff, which again I've only just put that in recently because I think I need it, but we'll find out later on. So once this is all done, it will do all this stuff. You can see it's running apt-get update. It's going to do all the install. And then just before I finish this video, I'll show you how we access these. Now, because they're virtual machines, you could access them in exactly the same way you would access any other virtual machine. So you could find its IP address, and you could log in using, you know, SSH, like from PuTTY or whatever. But actually Vagrant gives you functionality to do that. Because this is now running, in here I can type Vagrant SSH, and it will actually log me in with a key that Vagrant created and installed in that Vagrant box. So I'm now logged into this VM without having to have set up all of that SSH nonsense. And it's also given me sudo powers, which obviously I'm going to need if I'm going to need to do stuff here. So if I look, I've config. If I look at the IP addresses here, you can see that one there is the one that I specified in the Vagrant file. So that's the one I'm going to use to talk to the other Postgres servers and to Barman. It's just easier to have a static IP. You could get it to allocate one, but then without DNS set up, they're going to start losing track of each other. So it's easier just to have a hard-coded one. Whereas I think the 10.01 is the NAT interface, so that I can connect to the internet. But otherwise, this is just a normal Debian kind of box. So if I look in here, there's nothing in my home directory apart from the usual kind of Linux stuff. But it will already have Postgres installed because that was installed by the Vagrant file. So if I look at, say, you know, Postgresql 13 main, there's my configuration for the main cluster for version 13 of Postgresql. The cool thing about the folder strategy is that you can have multiple versions alongside each other, and you can have multiple clusters, and they can all have their own config. So for example, that PGHBA is basically an access control file. So this access control file only applies to the main cluster. So if you had that second cluster called events, well, events would have its own configuration file, and you could lock it down differently. So that's why you get the ability to have more than one cluster, but we will only have one. So that's enough for now. What we're going to look at in the next video is all about installing PostgreSQL, which we've already done, obviously, using the package manager. But then we're going to look a bit more of the configuration, some of the settings, where the settings are, and what we might want to set before we start creating our cluster, because there are certain values that you can't change once the cluster's been created, which you kind of want to get right in the first place. Not many, just a handful, but we'll see those in the next video. And then after we've looked at Postgres, like I say, we're going to go through Barman, and then we'll go through Rep Manager. So hopefully Vagrant's given you some stuff to think about. If you haven't set that stuff up, jump onto my GitHub link, find those Vagrant files, download them, and try and get yourself set up, because the more you can follow along, then obviously the more you're going to be able to understand how stuff works. So I will see you